Number 60, letter A. Another airplane is flying in a jet stream that is blowing at 45 meters per second in a direction 20 degrees south of east. Its direction of motion relative to the Earth is 45 degrees south of west, while its direction of travel relative to the air is 5 degrees south of west. What is the airplane speed relative to the air mass? All right, and let's just highlight this motion relative to the Earth over there too, because that's important. All right, so in terms of a picture, take a look at the left-hand side. I drew a coordinate system with all the vectors in place. All right, so it tells us that an airplane is flying in a jet stream, and that jet stream's velocity is blowing at 45 meters per second at 20 degrees south of east. So that is represented right here. It's the velocity of the air. Now, they don't tell us in relation to what, and it's very important to pin down, since this is a relative velocity problem, it's very important to pin down what this velocity of the air is in relation to. All right, so, or what it's relative to. So when they don't mention it, as they haven't done in the first part of the problem here, it is important then to note that that is usually key for us to then assume that it is relative to the Earth. All right, so when it's not stated what it's relative to, it means that it's relative to the Earth. So the velocity of the air relative to the Earth is 45 meters per second at an angle of 20 degrees south of east. Great. It also told us that we have that the velocity of the plane relative to the Earth, right here, is traveling at 45 degrees south of west, which it is in the problem, right? 45 degrees south of west. And then they also tell us about the velocity of the plane relative to the air is 5 degrees south of west. Okay, so in order to do this problem, it almost seems like we don't have enough information, but we do. So when we get to points like this, what we want to try to do is we want to think about summing all of the components up of these vectors and trying to identify which of these three might be considered the resultant vector. Okay? So in that particular case, what I'm going to do is I'm going to assume, let's see if this is the resultant vector. All right, the velocity of the plane relative to the Earth. How would I know that, or why would I think that? Well, take a look at the relative velocity formula on the right-hand side. Right? What that says is this: that the velocity of AC is equal to the velocity of AB plus the velocity of BC. Now, A, B, and C are all just relative terms, right? So what I'm going to do though, let me assume that this term is the velocity of the plane relative to the Earth. Now, if that's the case, that means in order for me to find this, I need to know the velocity of the plane relative to the air plus then the velocity of the air relative to the Earth. Okay? So if I assume that this is the resultant vector, right? Remember that resultant vectors are found by summing the x's and summing the y's, right? Adding them together, taking the square root of the squares of each, okay? So basically, what this is telling me here, that to find this resultant vector, all I have to do is add up the components of vector 1 and vector 2. And that's what we've done in the past. Now remember, these are all either x's or they are y's. Okay? Because if the vectors are not in the same plane, you have to break them up into the components of x and y and then add those together. All right. So now, in any case, let's see if we know these items. Meaning, did they give us the velocity of the plane relative to the air? Well, they gave us a direction of it, right? They told us that it's 5 degrees south of west, but they didn't give us a value. But that's fine. I could probably work with that. And then what about the velocity of the air relative to the Earth? Well, they did give us that too, right? And they gave us not only the magnitude of it, but also the direction. So it sounds like it works out nicely, okay? So meaning that this is probably the resultant vector, all right, of the picture I drew. But let's say you didn't know that. Let's say you, identified this as the resultant vector. What would have happened? Well, then I would have had the velocity of the plane relative to the air should equal the velocity of the plane relative to the Earth plus the velocity of the Earth relative to the air. Now, if that's my setup, do I have this, the velocity of the plane relative to the Earth? Yeah, I do. That would be right there, and they gave me the directional component of it, 45 degrees south of west, so that'd be great. But now what about this, the velocity of the Earth relative to the air? Do you see that in the picture here? No, right? You do see something close, though. You see that the velocity, we know the velocity of the air relative to the Earth, right? And there is a relationship between these two, okay? right? One is the negative of the other. Right? Remember that the velocity of AB is equal to negative velocity of BA. So if I were to use, let's say, this formula and assumed that this was the resultant vector of my picture, I would then have to create this vector from the picture. Remember, this one is the exact opposite of this one, meaning that in my picture, I would have to draw something that looks like this, right? That would be the new vector, okay? So, but if you notice, what's the pattern? Well, the resultant here that I assume it is the resultant, it lied in between two vectors, right? Interesting. Wait a minute. What did I assume here? I assumed the VPE was the resultant, and that also lies between these two vectors. The pattern is not coincidental, all right? So that's something how you can visually identify it as well. All right, so let's get rid of this stuff. Let's now try to take a look at calculating this stuff, all right? So basically what I want to do is I want to set it up in a component table, okay, component table, where in my component table I have X and Y components of each of my vectors, okay? These are the vectors I'm going to be finding the component. Actually, I'm going to find the components of them all, right? But this will be the vector of the velocity of the plane relative to the air. This will be the velocity of the air relative to the earth. When I sum them together, I then get the resultant vector, which is the velocity of the plane relative to the earth. Okay, and I have to break these all up into X and Y components. So let's do it. All right, I'm going to do one at a time because I think it'll make it a little easier to digest. So let's first work with the velocity of the plane relative to the air. So that was this vector right in here. All right, so we have a 5 degree, okay? Remember, this is just the velocity of the plane relative to the air. So it has an X and a Y component to it, correct? This would be the X component. Yeah, I'll make it a little longer. Right, that would be the X component. Now remember, this is negative, right? Because it's pointing to the left, negative X direction, and then this would be the Y component pointing straight down, and that would also be what? That right there would be a negative Y. Okay, so keep that in mind. So to find out our X component of this vector, right, remember we would use cosine. So cosine theta is equal to the adjacent side over the hypotenuse. Cosine of 5 would then be equal to negative, right, of the velocity of the X component, let's just call it, well, let me do it this way. Negative velocity of the plane relative to the air in the X direction divided by the velocity of the plane relative to the air. So if you notice then, this would be negative velocity of the plane relative to the air in the X component equals, so you just cross multiply here, right? This would then equal velocity of the plane relative to the air multiplied by cosine of 5. Okay? Now, just take this negative and then bring it on over. All right, so let me just erase it there. Whoops, went a little nuts there. So let me just erase it again. Let me get a little smaller one. There we go. And just plop that sign on the other side. Okay, so this we're going to plug in for the X component of the velocity of the plane relative to the air. So this is negative VPA cosine of 5. Great. Now let's do the same thing for the Y. All right, so this simply is now sine. So sine of theta is equal to the opposite side of the hypotenuse. So now the sine of 5 degrees is equal to, remember it's going to be negative because it's pointing down, negative of the velocity of the plane relative to the air in the Y direction divided by the velocity of the plane relative to the air. So again, I'm just going to distribute my negative and then cross multiply. So the velocity of the plane relative to the air in the Y direction should be equal to the velocity of the plane relative to the air. It's negative, right? Multiplied by the sine of 5. Okay, so take this value, plug it into your table. So this should now be negative of the velocity of the plane relative to the air multiplied by the sine of 5. Okay, very good. So that takes care of that one. Now let's look at the next one, the where is it? The velocity of the air relative to the earth. Okay, so let's pull. Actually, I'm going to do it on the chart because there's only one on that coordinate system because there's only one vector on the right-hand side. All right, so let's break this one up now. So here's the X component. Okay, that's Vx, it's positive. And then we have a Vy, and that looks like it's going to be negative. So keep that in mind. Okay, so let's first take a look at the x. All right, I'm not going to go through the formulas all the time, but it's going to be cosine. All right, so let's just simply look at it, right? This would simply be the velocity of the air relative to the Earth in the x direction is simply going to work out to be the velocity of the air relative to the Earth, right? Because that's the hypotenuse multiplied by the cosine of the angle. Right, so this is simply now equal to 45.0 cosine of 20. Okay, and let's calculate that number, right? So the velocity of the air relative to the Earth in the x direction should be 45 times cosine of 20. 42.3. Cool. So this becomes 42.3 meters per second. I'm just going to leave out all the units, but let's plug in the number. So this is 42.3. Okay, and now let's do the y. Now remember, this is negative, so that's important. Okay, so this will now be negative of the velocity of the air relative to the Earth in the y direction should be equal to the velocity of the air relative to the Earth multiplied by sine this time of theta. So just distribute the negative sign. Okay, so it's going to be the velocity of the air relative to the Earth in the y direction will be equal to negative 45.0 multiplied by sine of 20. Cool. And now the velocity of the air relative to the Earth in the y direction should be equal to, so negative 45 times sine of 20, negative 15.4. Okay, so this is now negative 15.4. So plug that into the table. All right, negative 15.4. Now, great, everything's good. Now here's the trick. Normally we would just add these two together and get the value here, but I'm not going to do that yet because why? Well, they gave me an angle of my resultant vector of 45. So what I'm going to do is now I'm going to break this vector up into its components and place those components in the table. All right, so let's do that. This one I'm going to draw another coordinate system for, just so we can clearly see it. I would do it right over here, very simply. So here we have our vector. It's at 45 degrees, right? This is 45. This is the velocity of the plane relative to the Earth now. So if we break that guy up into its components, yep, that's a little long. Here's the x component. Great, remember, this is negative x direction, and then its y component. And a little straighter, there we go. And remember, that's going to be negative as well, because it's in the negative y. So now let's just break each of them up individually, okay? Let's work with the x first. So here we have negative velocity of the plane relative. I'm going to run out of a little space. So let me just actually do a little magic here. Move this up. There we go. Okay. So let's now do, so it's going to be negative of the velocity of the plane relative to the Earth in the x direction should be equal to, right, the magnitude of the vector. So this is just the velocity of the plane relative to the Earth multiplied by cosine of 45. Okay, so I just did that all in one step instead of doing all the work out, but I think you guys got it from there. Right, so just distribute the negative sign on over. Okay, so let's just write that over here now. So plug that into the table. This is going to be negative then VPE cosine of 45. And I'm running out of a little room there. Sorry. It's tough to fit this all on the one page, as you can see. So let's just get this. So VPE cosine of 45. Cosine 45. Great. Now let's do the same thing for the y component here. Okay, remember that's just going to be negative of the velocity of the plane relative to the Earth in the y direction now should be equal to the velocity of the plane relative to the Earth multiplied by the sine of 45. And then just distribute the negative, okay? Let's erase that, put the negative there, and now plug that into the table. So this is negative VPE sine of 45. Okay, now, man. So now what I'm going to do is now I'm going to write my equations. Okay, so here's my x equation. So it's the x of VPA plus the x of VAE will equal the x of VPE. Say that 10 times fast. So let's write that formula out. I'm going to write it out over here. Put a little box, I'll put it right in here. All right. So let's see. All right. what I'm going to do, let's do this. So it'd be 42.3, right? Minus this term, minus VPA cosine of 5 is going to equal, right, negative VPE cosine of 45. Okay? So that's cool. So let's leave that. And then the second equation is this. All right, so this is equation 1. Let's call this now equation 2. So notice how they're all negative. All right, so I'm just going to make them all positive, right? Just flip them to the other side or multiply the whole thing by -1. So either way, it doesn't matter. So let's now write this. So this is going to be VPE sine of 45 equals VPA sine of 5 plus 15.4. Okay, great. So we're really close. Now, why do I love this? Well, I love this because I can solve it from here, right? I have two equations with two unknowns. What are the unknowns? Well, VPE and VPA. There's the unknowns. Two equations, two unknowns. How do we solve it? It's like a system of equations, right? Stuff you've done in high school. Okay, so let's first solve number 2 for VPE. Okay, because we have VPE sine 45. So really what we got to do is just divide out now the sine of 45. So this is the result over here now, sine of 45. And what I'm going to do is I'm going to take this whole thing, all right, and plug it in now for VPE in this formula. All right? I'm going to do that on the upper left-hand corner. So let's see if I can squeeze that in. So we have 42.3 minus VPA cosine of 5 times cosine of 5 will equal negative, put your brackets now. So this is now going to be VPA sine of 5 plus 15.4 divided by sine of 45. And then don't forget the cosine of 45. All times cosine of 45. Just ran out of room there, but I think you guys get that. All right. So now let's clean this up a little bit. Let me find a value for cosine of 5. All right. So this is going to be 42.3 minus cosine of 5, 0.996. 0.996 VPA will equal. So now let's take cosine of 45 and divide it by the sine of 45. Okay, so cosine 45 divided by sine of 45, guess what it's going to be? It's going to be a value of 1 because they're the same. So this essentially just cancels. So now we're left with negative VPA times the sine of 5. So let's just find that. Okay, sine of 5, let's get a number. And let me just reorganize it. So actually I'll put the number first. So it's going to be negative 0.0872 VPA, right? Then distribute the negative again. It's going to be then minus 15.4. All right. Now what are we going to do? Let's add this term on over to the left. On over to the right. Seeing if you're paying attention. And let's take this term now and add it on over to the left. Okay. So let's write the result. So it's going to be 42.3 plus 15.4. And that's 57.7. So we get 57.7. And that will equal negative 0.0872 plus 0.996. Okay, so that becomes 0.909 VPA. And look what we can do now. Oh my goodness. Thank the good Lord. Okay, so now here's VPA. Okay, so take 57.7 divided by 0.909. And look at that. Beautiful. 63.5. 63.5. That is meters per second. So that is the velocity of the plane relative to the air. So I think that's what question A was asking, right? What is the airplane speed relative to the air mass? So there we go. We got it, guys. So we did letter A. So I can erase this little question mark over here now. And I'll plug in the value. So this is going to be 63.5 meters per second. Now, what's the part B? It says part B, what is the airplane speed relative to the Earth? All right, no big deal. Take now one of our equations. Let's take equation number 2 that we solved for earlier, right? So this is going to be, this tells us that the VPE, which is the velocity of the plane relative to the Earth, should be equal to VPA, right, times the sine of 5 plus 15.4 divided by sine of 45. Sine of 45. So all I'm going to do here, guys, take this value and just plug it on in. And then I'm just going to calculate. Okay? So VPE now should be, so 63.5 times the sine of 5 plus 15.4, and then that is all divided by sine of 45. Ah, there it is. 29.6. 29.6 meters per second. And now I know this one right over here, so I'm going to plug it on in, right? So this is just going to be 29.6 meters per second. Oh man, thank God that's over. Okay, so guys, thank you so much for tuning in. I appreciate it so much. I hope this helped. It's a very long problem, hard problem, but if you can do this, the test honestly should be a cakewalk. All right? So please try to understand this as best as possible. And if this helped you guys out at all, I'd love if you can subscribe and tell your friends too. That would mean the world to me. All right? So thank you again, and I'll see you in the next lesson.